earlier we zoom in on the histogram is right here. So then you can get a better sense of how the values are distributed. Many of the county's burglaries actually fall within the bottom 0.5% of the value range below an axis value of 196.5. The data is skewed toward the low end of the histogram, meaning that there are relatively few burglaries in these counties. The mean number of burglaries is 138. A gray column will not be drawn if no features fall within the value range it would represent. The number of columns can be set to anything from 10 to 100 within 10 columns. For instance, each would represent 10% of the value range. So now in the column box, we're going to change 100 into 25. To 25. We're going to type in 25, and not yet. I'm going to bring this window back. And now the gray column, we notice, represent 1/25 or 4% of the value range. In the classification frame, and we're going to click method and go to interval. Equal interval. And we can see some changes, number changes, of course. The class breaks are now equally divided. Still in 3 classes, this method places breaks so that each class has the same range of values. Almost all the values fall into the first class. Unlike the natural breaks method, each equal interval classification, it is possible to have classes that have no values. So we are going to look at the classification frame, and we're going to click the method to quantile and see what changes. Now we click to quantiles. The quantile method creates classes that have an equal number of features. And then we going to click OK to close the classification dialog box. The current classification settings are updated to reflect the quantile method. And we see a lot of different changes. So when we hit apply and we move the layer property dialog box away from the map display, the map looks much different from the previous classification method. Many more counties now fall within the highest burglary class. As this example shows, the way you choose to depict data can provide different impressions, some of which can be misleading. You will have to adjust the classification method again to use natural breaks. On the Symbology tab, we're going to click classification. On the classification dialog box, we're going to go back to natural breaks and hit OK. Hit apply. And however, here we're going to change the classification to 7. You can do it from here, or you can just do it from here, and then you hit apply. That we hit OK. And before finalizing the map, we will have to make a small changes to the class labels to make them look better. So in the lower section of the Symbology tab, click Label Column Heading and click Format Labels. So click this label and label format labels. Format labels. And then a window will pop up. The number format dialog window will pop up. The number format dialog box has options to edit the look of the numeric labels. This does not affect the classification values, but only the way they appear. You can control the number of decimal places and significant digits, alignment, and whether to include comma separations. You can even choose special formats listed in the category box. So, on the number format dialog box, change the rounding number of decimal places to 0. Numeric, and then rounding number, change 6 to 0. Also, we're going to select show thousands of separates, and then we're going to hit OK. And then you see there is a huge change here. Now we close the number format dialog box, and now the symbology tab, and then we can see here it changes in, but the layer here right now, it doesn't change. When we hit apply, and we can see right here it changes as well. And then we're going to hit OK, and here is data view. We change it into layout view, and the Texas Berkeley County level 2002 already created for us. Now we're going to click the full extension view. That the layout includes a legend, then already show the 7 classes created using natural breaks. And now we're going to move, we can save our work. Now we're going to continue, so we are not going to do anything for now, but we're going to close it out and then click exercise B, mapping density. When we turn it on, and this map document will open in a map layout view. So you can see the table of contents. There is a single active data frame called motor theft per capital. The motor theft per capital data frame has 2 identical counties layers coming from the same data source. You will make a population density map that is overlaid by a dot density map of motor vehicles theft. So we're going to click back to data view, not layout view. So this is layout view, back data view. And we're going to the county 2 layer. We're going to open its attribute table. So the population attribute contains the population count for each county. The area square miles attribute contains the size of each county in square miles. So now population and area square miles. Next, we're going to divide the population attribute by the area square miles attribute to create a ratio of population density for each county. So it is very easy. We're going to close this. We're going to use these 2 fields, but not in the table by itself. We could calculate add a field, but we don't have to, because the symbology tab has the function for us to help us to do that. So now we're going to click quantities. Then then we under the show here, and it's quantities and graduated symbols. So here the value we're going to apply will be population. And the nominalization, if you're good at math, of course, it will be area square miles. Then we set the color ramp to red, light to dark. And red, we don't know which one, so we're going to look. R, it will be down below, red, red, light to dark, red, light to dark. So the natural breaks, Jenkins, classification method is chosen, and 5 classes are defined. In the label column, the labels are rounded, but the decimal places are not consistent. See, we have a 0.1, sometimes we don't have anything. So we're going to click that. Just click label, and you have a small window pop up. You have 3 options. We choose the middle one, format labels. And we're going to delete this. We're going to change the number 4 to 2 in this case. So we click the label column heading and click Format Labels on the Number Format dialog box. Select the number of decimal places option and change the number to 2. And we're going to click OK, close this Number Format dialog box. And click OK to close the Layer Property dialog box and select the checkbox hit apply and hit OK, and then we're going to right click on the first layer. Actually we just uncheck this, so now we can see the second layer. Make it invisible. So the class with the greatest population density has 3 counties: Tarrant, Harris, and Dallas. You can verify this using the Identify tool. The next highest class contains 4 other counties. The remaining counties of Texas have a low population density. Graduated colors are one way to represent density. Another way is to use a dot density map. Now we back to cartography basic. So I'm going to talk using the last minute to talk about what is the choropleth map. So a graduated color map uses a change in colors to represent data classification. A ramp with a single color called monochromatic is suited for data that moves from small to large values. Sequential schemes such as population increases can be shown within light color for smaller amounts of change and dark colors for large amounts of change. A ramp with 2 colors can be used to represent a divergent scheme, such as population increase and a decrease. The extreme values are shown in dark colors and the middle value are shown in light colors.